Welcome to EDU World Space.
Okay, so this is question number 23.4 of chapter 23. So we are given that there are two charges here, means that two protons here. So both have positively charged electron charge. So this is 1.6 into 10 to the minus 19 coulomb, and the second one is also having the same charge, which is plus E charge, 1.6 into 10 to the minus 19 coulomb. So we are given that before the two protons, we say Q1 and Q2 here. So Q1 is the first proton and Q2 is the second proton. So at beginning they are at 2 into 10 to the minus 10 meter. So it's a very small distance, but they are some at distance here. And we move them very slowly. Very slowly means that we do not provide any kind of kinetic energy here. And they move to a very small distance further. So this is 10 to the minus 15 meter. That means they are much more closer now. So we are asked to find out how much work would it require. That is A part. And in B part, if they are released from this position, from Q1, Q2, at this position after, and so if because both are protons, so they would repel each other, and they would repel each other to make it the distance farther and farther, so the distance increases. So the question is, if they are at this distance and the force between two protons act on each other, so they would repel each other. So after how much kinetic energy would they gain if they reach to this distance now? So first situation is this one. So A part, we are in this situation, so this is A part. So this becomes in B part. So this is our final situation in B part. Okay, all right. So now we have here formula here, U equals to 1 by 4 pi epsilon Q1 Q2 over R. So this is potential energy. Remember that W here is equals to delta U, not minus delta U. Let me write again. So we have delta U, W equals to minus delta U when when W is work done by electric force. Now this is not, we are asked to find out how much work would it take from the outsider. So outsider means that the someone is applying some force from outside to make it closer. But W, this one which has the negative of the delta U, is the work done by the electric force itself, or the force acting between those two protons. So we must have this plus formula here. So we will use this formula. So remember the difference between these two. This is the work done by the outsider. This is the work done by the electric force. So we have electric force. We say that W by electric force equals to minus of work done by agent. All right. So this is a very important understanding here. Okay, let's solve the equations first. Okay. So we have U equals to 1 by 4 pi epsilon naught Q1 Q2 over R. So my W becomes delta U, means that U final minus UI, which is equals to 1 by 4 pi epsilon naught Q1 Q2 1 over R final minus 1 over R initial. So we have R initial this one for A part and R final this one. So we put these values and we put also the value of the 1 by 4 pi epsilon naught. So this becomes W equals to 9 into 10 raised to power 9 So this 1 by 4 pi epsilon naught has this value. We multiply now with the q1 and q2. So this becomes 1 into 6 into 10 raised to power minus 19. So we put a square because both are same charges. 1 over our final is our 3 into 10 raised to power minus 15 minus 1 over initial r, so which we have 2 into 10 raised to power minus 10. There we go. You can use the calculator to find out the values. So I have used the calculator here. So this is equals to 7.68 into 10 raised to power minus 14 joule. So that is the work done by the outsider or the agent, let's say agent, to bring those charges to closer to 3 into 10 raised to minus 15 meter from 2 into 10 raised to minus 10 meter. Okay, so this was part A. Now we go to the part B now. The B part says that we have this situation now, and now both charges repel each other and they move apart at this distance. So they must gain some energy, right? So when they move apart, so we have kinetic energy equals to half m1 v square plus half m2 v2 square. This is the proton, first proton having velocity v1. So this is the proton second having velocity v2. So this must be equals to the work done by agent. So this much energy or the work done now is now converted into back into the kinetic energy. Now remember the m1 and m2 are equal. So they must have the same velocity. So we have equals to half into 2 mv square, where m is the mass of the proton. Now 2 is coming from the same factor which we have say that m1 equals to m2 and v1 is also equals to v2. So both protons have equal velocity but they are moving in opposite direction. So we put this, so with 2 cancels down. So we use this equation now to find out the value of the v here. So this becomes v equals to under root of del WA. Now remember WA is simply equals to delta U. Change in potential energy equals to work done. Equals to gain in kinetic energy. So we use this. So we have this m here. M mass of the proton is 1.67 into 10 to the minus 27 kg. So v equals to 7.68 into 10 to the power minus 14 over 1.67 into 10 to the power minus 27 kg. So this becomes this one. So using the calculator we have, so we have 6.78 10 to the power 6 meter per second. So that's the velocity of each proton when they reach to the same distance when they were earlier of each proton. Meaning that after coming from these two positions, so let's say we use this one here. So when they were at these positions, now they went to this position now, or saying that is actually they were at this position. Now they are at this position now. So the distance has increased. So when they were at this position, now they are at this position. So the velocity of this particle and this velocity particle has this one. So that's your answer. Thank you.